Okay, I think it's recording now. Um, Hello everyone. Welcome to our CSCI 111 final review session for Professor Chyn, powered by Queen's College Learning Commons. So we have a lot of materials to cover. Um, this list I am showing here on the screen is from Professor Akinler. Someone in the chat can correct me if it's something similar for your course, if Professor Chyn gave you any structure for final. If she didn't, I'm gonna assume this is quite similar because almost all the professor for 111 does. Someone raised their hand. Yeah, go ahead.
Yeah. Um, so for me, she showed that there was going to be six questions. So one is a
Okay.
title line, another is an output, another is a function implementation. The
Wait,
fourth
title
one is
line.
pattern
Uh,
printing,
could you
and
say that one more time? Title line and then output and then what?
so yeah, first is title line, second is output, third is function implementation.
Okay.
Fourth one is pattern printing. The fifth one
Okay.
is recursive function, and the sixth one is array.
Okay, I see.
hmm
Okay, so we can just use those then. For the function implementation portion, did she mention which what kind of topics will be covered or just anything in general?
She didn't say any particular topics that are going to be involved. It's just like we just actually just went through like the practice sheet and see what that function flotation question is going to look like for the test.
I see. Okay,
Yeah.
cool. Did you guys cover strings in the class?
Say it again.
Did you guys cover strings, like string methods?
Oh yes, yes.
Okay, so I will cover like function implementation. I'll cover string, just to give you some idea of what's going on. Did you guys cover command line arguments?
No.
Okay, so this can be gone. Pattern is there. When you say array, you mean 1D and 2D, right?
Um, the ones that I did, I think most of them were 1D arrays.
She said the title line will be provided.
I think most of them were 1D.
Yes, I'm not sure what you mean by title line will be provided. This part is basically asking you to write title lines. We can go over some examples to
hmm
showcase. For arrays, I'm gonna assume it's 2D because assuming everybody covers 2D in the final. Um, Also, do you guys for the output questions, is it part of the pass by value, pass by reference thing?
Yes.
Okay, cool. Okay, so we can cover this then. So I'll just skip everything here. Actually, let me just say, ching. Okay. So we can get started. I'll start with that title line. If you guys have any particular topics you want me to cover before title line, then just let me know. Otherwise, we can get started. There's a lot of materials to cover.
Actually, there's one specific part about the title line questions that I would like to like go over.
Sure.
hmm
Do you have any particular questions or particular stuffs?
yes.
Sure. It would be great if you can provide the examples or something.
hmm So, question 13.
Question 13. Let me see 1 second. 13. Is it this one?
No, the question 13 that I have for mine is different.
Could you share the question in the chat so I can just copy paste or something? Or send a
Yes.
screenshot. I don't know. Whatever
Yeah.
makes.
I'll do that.
The people who joined late, could you guys please fill out the attendance form?
Just put it in the chat.
Okay, got it. Let me copy that. Okay. The indentation is a bit off because the Zoom did their thing. but let me see.
Oh,
Okay, that looks good.
also ruined the
That's
way
okay.
they
No,
would
no,
have.
no
Okay,
problem at all.
all right.
Okay, so we can go over this example for title line as someone provided. So we always start from the main function, and we go line by line. So part A is this, part B is that, C is that, D is that, and E is that. Okay, so first part says make a variable called nn that is equal to 5 and make an array called num of size 3 and the values are 0, 1, and 2. And you guys are familiar with indexing, right? Arrays always start with index 0, then the next item is index 1, and the next item is index 2, so and so. So next part says make another array called RL, but now the types are double here, and the values are 1.9, 2.3, and 3.0. Okay, and the next part says make another variable called ch, and that has the value b as a character. So now the first function comes swap and then blah blah. So first thing we do for title line questions, we look. I personally look at the parameters or the arguments. So I see there are one comma. So there's one parameter before the comma and one parameter after the comma. So it has two parameters, right? So let me just quickly start writing the answer. So we have swap, and it takes two parameters, right? First one here, second one here. What's the type of the first parameter? First parameter is this guy, num at 1. So num itself is an array, but num at 1 is basically going to the index 1, and what is the value at that position? The value at that position is always an integer because num was declared as an integer array. The first item has to be an int. You can name the variable anywhere you want. I just call it A, B, C, D, E, just for the simplicity. The next part is nn. What is nn? Nn is also an integer as defined above. So next part is also an integer, int b. And what's the return type? So it did not say what it does, right? For example, on the next function, well, let me think. It swaps stuffs. So for example, this line says next line will print this. So that means this function outputs that value, like 3.14, blah, 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 right? But since our current function didn't say what it does, or it didn't store the value anywhere, so it's safe to say this is a void function. Also, I don't have the answer key. So if I am wrong from the answer key, just let me know so we can get the correct answer right. But since it doesn't say what it does, and the value is not stored anywhere here, so it doesn't do anything except maybe swap stuffs. So we're gonna call it a void function. So the next line says it's a cout. So num at 1 gets you p, get prints 5 and 1. Okay, so that means I see what's going on. So this line is saying num at 1 is printing 5 and then nn is printing 1, right? That means the swap function basically swapped these two values, right? The num at 1 became num at 1 become 5 as nn was 5, right? This became 5 and the nn, which was originally 5, it became 1. So basically that swap function actually swapped those two values that was passed in the parameter. So I just swapped them in the memory, right? Moving on. Now we call the remove function, which is the second part. How many parameters are there? There's two commas. So there's three parameters, one here, and one here. So I'll start writing the code. Remove. So first one, second one, third one. First one is nn. Again, nn is an integer as defined here. Even after changing the value, it stays as an integer. So I'll just call the first one is an integer, int a. Second one is num. Now, num, this one is different than num set 1. When I say num at some value, like 1, for example, this is the item at that index. The item itself is an integer. But when I just say num, num is an array, right? When I declared here. So we cannot just say it's an integer, it's an integer array. So for the second parameter, I have to say it's an integer array. And you can name it whatever you want, B, ARR, whatever, it doesn't matter. And the third part is the number 3. So number 3 is always an integer. So it's always an integer C. Okay. Also, if anything doesn't make sense to you guys, just you forgot to add the ampersand. Oh yeah, that's true. Yeah, that's true. Yeah, I forgot that. Also, if something doesn't make any sense, just let me know. Because I'm not reading the chat and doing the problem at the same time. So there should be ampersand because they swapped in place. They do not swap. Like I would say the rule of thumb is when you do swap function, you always do ampersand. Because swap has to be permanent. Like if you don't do ampersand, then the swap doesn't permanently change the thing I changed here, right?
Oh, I have a
So let's,
question.
yeah.
Okay, so how do we know that they're being called by reference here?
You don't, well, the way I know it's because when I printed here, like
Mm-hmm.
this line swapped them, right? The num at 1 was initially 1, but it became 5.
Yes.
So that
Yes.
means that whatever the swap function does is permanently
Oh, it was
changed.
affecting what was
Exactly.
it was affecting the parameters outside of it. Okay.
Okay.
Yeah, because I had everything but those ampersands. Okay. I
Yep.
see.
Okay, so the remove function does and it doesn't even say what it does again. This function, there is nothing that's being printed or nothing like that. So I'll just assume the return type is also void. Same idea as the other one. And then the next line prints 3.14. So now this function qn, also I know this is a function because it has a opening parenthesis and closing parenthesis. Every function has opening and closing parenthesis. So the next function is this guy qn, and it has two parameters, right? One is the RL and second one is the 3. So I'll do two parameters. What is the type of the first parameter? RL. RL itself is an array of type double, right? Like that. If I had RL at 1, then the item is just a double type, not an array. But since we just did RL, similar to when I did num, it's a double array. So I'll do double, and then I'll call it an A. I don't know. The second item is the integer 3. So I'll just say it's a int b. Um, One thing you gotta know, like variable name doesn't matter, just make them distinct. Like don't say a here and then a here again. That's the only restriction. Otherwise, you can name them whatever you want. You can name them mouse and keyboard. It doesn't matter. And the line above told us that the next line is gonna print this value, 3 point blah blah blah, which is a type double, right? This is a type double. That means whatever the result of this guy is has to be a type double because that's the one that's been printed. That's mean the result, which, or in other words, the return type has to be type double. Okay, and then moving on. Next line says call the function d with num and 2. So it has two parameters. Obviously, first item is the num array, and second item is the value 2. So num, well, not num, d is the function name, and the first value is the array of integer, call it a. And the second item is another integer, just call it b. And what is the return type? So, okay, so it's gonna be tricky because the return type depends on the next line because I see this function is also used here. So I have to be careful what do I put in this position, which is the return type. So let's just keep it empty for now and let's just do the next question. Then we can figure out what's the return type of the D part is. So next part says E. Now it's a nested function, like triple nested function. So when I see nested function, I always go from inside out. In other words, if I kind of like separate them, so you can see that, let's say this is a part. So this function ends here. Sorry, this function ends here. And then this function ends here. This is the function. And then we have, this guy followed by that guy. Okay, so now we kind of separated them. So every function, since they're all E, they have to have the same input and output, meaning the same arguments. or same parameters and same return type. So just looking at this portion itself, right? And not including that part, just this portion itself, it has two parameters. First parameter is a type Boolean because only Boolean has true or false value. Second item is ch, and ch is a character, right? As defined here. So that means for the function e, there's gonna be two parameter. Uh, Let me get that person in. Someone requested to join. Oh, Lauren is here. Nice, great.
Yes, I'll be answering questions in the chat. If anybody has any questions, feel free to ask.
Great. Okay, so looking at this portion alone, it has two parameters. First one is a type Boolean because only Boolean has true or false value. Second item is the ch. Ch is a character. So I will say the first item is a type Boolean, call it a. Second item is a type char, call it a b. So now what is the output here, right? Now, if you look at this portion, let me put another color here. Let me use orange. I don't know. If you look at this portion, not up to that position, up to this position. So this value, what I got from the innermost function call is the second argument for this orange guy, right? For this orange guy, the first argument is true. The second argument is what I put in the box, right? Now the box itself is the return value of that function. So that means whatever I return here has to match my second parameter of function e. Now, second parameter of function e, I already said this is going to be a type char. That means the box has to be type char, so so only that way the e can have second parameter as type char. That means the output also need to be a type char. Only then this char becomes the orange box to be a char, and only then the orange e takes the char value as the second parameter. And that's how I knew that this is a char return type. Any questions so far on this part? If not, then I will move on to the portion we just skipped, right? Which is the return type of D.
I have a
So
question.
yeah, go
So
ahead.
I always when I was doing the practice problems, I always noticed a pattern where like it's always the last two D and E, where like they have like that bit of ambiguity of like what's the return type, right?
Mhm.
And I always try dissecting it, but it always takes me longer. Like I did get this right, but like it's always when I get to this part, it always takes me longer. So like, what's like the fastest way of like approaching it?
I don't really have a fastest way. When I took the class, I was also struggling. I'm only better now because I already passed the class a long time ago. I
Hmm.
would say if I'm taking the first time, I would always go from inside out, like I did here. When I go
Okay.
from inside out, I can at least get the arguments correct, right? Like these two
Hmm.
can be correct just from the green portion. But for the return type, it can be tricky, but you just follow what I did, right? The
Yeah.
return type is basically the result of this orange box. But
Hmm.
the orange box itself is the second argument of this guy. But I already said second argument has to be a type char. That
Hmm.
means the orange box also need to be type char. Only then the E can take char as a second parameter. And since the orange box is the result of that function, that means char has to be the return type of that function. So that's why this is a char.
Okay.
Okay. So the only part I left was the output or the return type of D. So now if I just skip everything here, I see that D is also used in this line, which is this part. Now this part is the first parameter of this function, right? The E function, the very outermost E function. For the very outermost E function, the first parameter is this box. The second parameter is this red box, right? But I already said the first parameter has to be a type Boolean. Second parameter has to be a type char. I don't really need to know what's going on on the second parameter because that's already fixed. But for the first one, it has to be a type Boolean because I already declared here. That means whatever is resulted from this orange box also gotta be a type Boolean, so E can take it as a first parameter. In other words, this guy I skipped also gotta be type Boolean because that's the first parameter of this E. And the first parameter of E is always a type Boolean as I just did here. Okay, so I will just type down Boolean here. Um, Same idea as the part E, it's just going back and forth between part D and part E here. So it's a type Boolean. Any questions so far? Let me see if it's anything on the chat. Hopefully they didn't.
No, you're good. There's nothing
Okay.
there.
Okay, so if you guys don't have any more questions for the title and questions, then I'll move on to a different topic. Maybe I'll go over, I don't know, output questions, past available as a reference. For any topic, if you guys have any particular question you want me to cover, just let me know in the chat. Otherwise, I'll pick something on random from the problem sheet I have. Okay, let me pick a question for the output type. So Lauren, are you a co-host of this session? You are, right?
No, I was not made a co-host.
Okay, let me make you co-host because I want you to have the incoming people invite join. There you go.
Got it.
Okay,
Okay.
let me pick something for the best by value. Well, let's do this one, I guess. Someone raised their hand. Yeah, go ahead.
I have a quick question, guys.
Sure.
Um, I have to go somewhere to handle an errand. I just wanted to ask, since it's late at night this time around, what time will the review be posted? Because I was gonna look up the and watch the reviews from previous sessions
I
or
am not
previous
exactly sure, but it's usually within 24 to 36 hours.
24 36 hours.
Yeah,
Okay, so around like Sunday in that case.
probably before that, like probably by tomorrow, like Saturday night.
Okay,
But
that's cool.
by Sunday, you'll get it for sure. Yes.
Awesome. Thank you, guys. I hope the session goes good for y'all.
All
Thanks
right, no
again.
problem. Thanks.
All right.
Oh, also, if you didn't leave, please fill out the feedback form before leaving. I know it's just the beginning of the session, but just do it. So this is one of the pass by value, pass by reference output questions. So I'll just go over this. Okay, so we always start from the main function, obviously. So main function does main function first line, it makes an array. We name of the array is size. I mean, name of the array is A, but it has size 6. First value is 1. Second value is 7, 7, 1, 4, 7. And I'll also put the indexing above them so I can keep track of which value I'm looking at any given time. Next line of code does two variable b equal to 2 and c equal to 3. Then we come to the actual outputs. So first part says go to the A array and go to this index. What is that index? Is b is 2 right now. So go to the A array and look at index 2. Index 2 is the value 7. So that means this guy is actually the value 7. Similarly, A at C is go to the A array and looking at that index. Now the C is at index 3. So index 3 has this value. That means this guy has the value 1. So if I add them up, 7 plus 1 gives you 8. Let me just put the answer in a different color so we know which are the answers. Okay, 7 is the first value and 1 is the second value. So add them up and you get 8. Next line is calling the function we just that was given above, right? It's this part. So now for the function, the second parameter only is passed by reference. So that means whatever changes I make to y is permanent on the main function. But whatever change I make for x is not gonna be reflecting for the main function. So we call fun with b and c. That means b is 2 for now. So my x is 2 here. And c is 3 for now. So my y is 3 here. So now the first line says, is x equal to y? Obviously they're not. So we don't do that. Now next line says, is x more than y? It's also not because 2 is actually less than 3, not more than 3. So we don't do that. Now, since this condition failed, so the next else will be true because in the if else block, one of them will be true, right? Either the first condition happens, then we do the first line. If it doesn't, then we do the second line. So since the if condition didn't happen, so we do the else portion, and else portion makes x equal to x plus 1, right? Like x plus plus is the same thing as saying x equal to x plus 1. So that means whatever I had, 2 becomes 2 plus 1. In other words, this line makes x equal to 3. That's what this line does. And then we return that value. So that means the function is returning me the value 3 here, because the value was changed here, right? But again, this one was passed by value, so I didn't make any change into the actual memory, right? Or actual the variables that I passed in. So that means this guy is going to give me the value 3 because this function gave me 3. So 3 is my answer here. That's the only thing that's going on here. Okay, so now we go to the next line of code. Next line of code does a for loop. Now we are doing a for loop. It's how many times? So initially r equal to 3, then r equal to 4, then r equal to 5, and that's the end of the for loop, because when r becomes 6, this condition is not true anymore. So we don't do that portion. So we only do these 3 times. Every time we call the function, right? So let's see what it does for every time we call it. So every time I call it, I call function with r, which is in the for loop, as the first parameter, and c as the second parameter. So first time we call it r equal to 3, so x equal to 3, and c is so far also 3, right? So y is also equal to 3. So in this portion, obviously this line of code is true. X is equal to y. So we're gonna print out y. What is y? Y is 3 here. Since we already printing out, so I'm just gonna write down the printed portion because this is the output question. This 3 came from this line, right? Which was when x equal to y. So now I go to the next line of code. Next line of code says x greater than y. Obviously it's not. So we don't do this portion. So now obviously since we didn't do the if condition, we're gonna do the else condition. And else condition is gonna make x equal to x plus 1. So x becomes 4 here. And that's the value we're gonna return here, right? That means this function, the first time it was called, gave me 4. And that's what the console output here, right? That means this guy, the first line, when I called it here, was initially printed 3 from this line, and then it also printed 4 because the function itself returns me 4, and the 4 is going to be couted here. So that means 3 and 4 is just from the r equal to 3 portion. Okay, moving on. So now r equal to 4 now. So r equal to 4 meaning x equal to 4 because r was the first parameter. And c still will. Give me a second. Did we ever change the y value? I did not, right? I did not. Yeah, I never changed the y value, so I didn't have to change. Okay. So c right now is also still becomes 3 because we never changed the c value. So it still stays 3. So now we do the function again. Is x equal to y? Obviously they're not, so we don't do that. Is x more than y? It is, right? So now we're gonna do this portion. This portion makes y equal to y plus 1. In other words, y becomes 4 here. But also remember, y is also a reference. So that means the second parameter is c here, also need to be updated. C was initially 3, but since I made y equal to 4 here, that means c also becomes 4 because c was a pass by reference into this function. Okay. So since we did this this line, so I'm not gonna do this line because if else condition only runs to one or the other. So now at the end we return x, and what is the value of x? X was 4 here, right? And we never changed x in this function call. That means this function gave me 4. So that's the part. This part gives me 4, and that's the part I'm gonna console out. That means the output is going to be 4 here, and this 4 is just for this function call when r equal to 4. So next time I call it, r becomes 5. So let's do it one more time. R becomes 5, so x becomes 5, and y right now is not 3 anymore because the c that's going to be passing has a value of 4 now because we just changed from 3 to 4 from the previous function call. So my y becomes 4 here. So now we do the line by line. Is x equal to y? Obviously they're not. Is x more than y? Yes, they are. So I'm going to update the y. So that means y becomes 4 plus 1, which is 5. Again, y was the second parameter, which is the pass by reference. That means the second parameter, which is c, I also need to change it to 5 because that was passed by reference in the function call. Since we did the if condition, so I'm not going to do the else condition. And then we return x. What was the value of x? It was 5 originally. I never changed it, so I can keep it as it is. That means this guy gives me 5, that guy gives me 5, and that's the end of the for loop because we don't do r equal to 6, because r equal to 6 make this condition false. And that's the output for line C. Okay. If you guys have any questions, just let me know. Otherwise, I'll move on to the next part. Okay, so moving on. Next part is ENDL. Well, ENDL that doesn't have any parts, so I'll just move on to the next part. So now we're calling the same function, but we're passing in two values. So now we have to look at the array. So a at 4 is this guy, right? Because the index 4 has that value. So that means the first value is also 4, because 4 was actually the value, not the index. I'm not looking at the index, by the way. I'm going to that index and looking at the value. And for this example, the value happens to be the same value as the index. So, and then a at 5 is looking at this index 5, and the value is 7 here. So that means the second value is going to be 7 because that's the a at 5. So now doing the function, oh, by the way, there's a semicolon, right? So this part itself is different than, oh, sorry, different than the cout. So let's just do the first part. So function call with x equal to 4, y equal to 7. This condition is obviously false because x is not equal to y. X is not also more than y, so this condition is also false. But now since the if was false, so else will be executed, and else condition makes x equal to x plus 1. So x becomes 5 here because x was originally 4, 4 plus 1 becomes 5. Since x was a pass by value, so I never changed the array, right? So x becomes 5, and then we return x. That means the function is giving me the value 5. But see, this function is giving me the value 5. But are we printing the value here? No, right? Because this function is only just calling the function. All this time we call the function, I counted the value. I look at this portion, we counted the value. Similar to this portion, counted the value. But on this part, we didn't see out the value. So even though the function gave me the value 5, I'm not gonna put 5 here because 5 is not counted or console output. Just keep that in mind. So we didn't do anything for so far, but now looking at the next part says cout a at 4. What is my a at 4? A at 4 is the value 4. That means this guy is gonna give me 4 here. And that's the part for line D. Okay, just make sure that there is a cout or there's not a cout. If there is, include the value. If there is not, don't include the value. Okay, so this part is done. Moving on to the next part. Now we call this guy now the same function, but now you see now there's a cout here. So now we're gonna print out whatever the value the function returns. So a at 1 is the value 7 because a at 1 gives me the value 7. So that means the x equal to 7 here. And a at 3 is the value 1, right? So this guy is 1. So this guy is also 1. So now going to the function, is x equal to y? Obviously they're not. Is x more than y? It is, right? So we're going to update the y value. That means y becomes 2 here. Also, y was a pass by reference. That means the second parameter, which was this guy, has to be also changed. So a at 3 was originally 1 in the memory. I'm going to change it to a 2 now, because we just did this line of code and this line of code was passed by reference. Since we did the if condition, I'm not gonna do the else condition. So then we return the value of x, and we never change the value of x actually. So we're gonna print out 7, or we're gonna return 7. So this function gives me the value 7. That means this part is giving me the value 7 here. And since now we are counting the value, that means the result is gonna have 7 just from that function. So now moving on, now we're gonna print out cout at a at 1. And what is a at 1 is also the value 7, right? Going to the index 1 of that array. So I'm gonna print out another 7 here. And that's the end of the line A, and that's actually end of the function. So these are all the answers for this part. If I'm wrong, can someone correct me if the answer sheet has a different answer? If not, I will be moving on to a different topic, unless someone have any questions on this part. Sure, we can go over recursive questions, yes. Okay, so looking at the list, we did title line, we did output question. So let's just go through a recursion problem. So someone said recursion, so my list is different than your list. Could you paste the question in the chat so I know which question you're talking about? Because my number 24 is different than your number 24. So if any of you guys joined late, feel free to read the not the feedback form, the attendance form. That helps us host more review sessions in the future. Um, okay, this is the part I hate the most for this class, pattern printing. Not that it's hard, it's just a lot of calculations to be done. Like what math equation gives me what part of the array, the printing version. Okay, so actually it's gonna be 22. Okay, we can do that. Let me copy that. So it's gonna be 22. Okay, so this is the question someone pasted in the chat. It's a lot of question parts. Wow. Hopefully it's not too small. I'm trying to drive the first parameter. Implementation of this function person. So this is the code. Okay. Okay, so the recursive function contains digit, uses two parameters. The first represents a positive integer, and the second represents a digit. Okay. The function returns a result of true if the first parameter has the second as one of its digits. Okay. It is applied in another recursive function, remove duplicates, okay, which is this part that returns. Let me indent them so I know which are the functions. And then this is the main function, okay. Where were we? Then returns a result that keeps only the leftmost occurrence of each digit in a positive integer. For example, that gives you 1, 2, 3, 4. Oh, I see. So this one is removed. Then this 3 is, no, this 2 is removed. There's a duplicate. And this 3 is removed. Okay. Implementation function with parts of code covered are given below. So some parts are given, okay. There is also main program uses them. Some pieces of code may be replaced by part A, B, so on. Okay, cool. So they gave you almost everything. You just have to fill up the part A, B, C, D, E, right? So going to the first part, what is part A? So part A is this guy. So this guy is the contains digit portion. So what is contains digit does? Contains digit. Okay, so for recursion, you guys are pretty much familiar with it, I'm assuming. It always has two parts. First part is the base case, where the recursion stops. Second part is the recursive case, where we call the same function, but with a smaller input, recursive case. We pass in a smaller input so that it eventually returns or eventually reaches the base case so we can return something from it. Almost always the base case comes first. So I'm gonna assume Well, it's almost always true. So let's just do the portion. So contains digit said, for example, right? If I say contains digit, I'm gonna call it C and D now. If I pass in 1, 2, 3, 4, and the value 3 here, this guy should give me a true value. Actually, let's just call it T for now. I don't have space. This guy should give me 2 because 3 is part of the function, or part of this number, right? If I pass in a 5 here, then this guy becomes false because 5 is not part of the number. So how can we do this? For any number, when you call recursively, it's almost always these two operations, mod 10 and divide 10. Um, mod 10 gives you the last digit. I'll just call it LD. And divide 10 gets rid of the last digit. So I'll just say remove last digit. So why do we need this? Because this guy gives you a smaller input than the original call, and this guy takes care of the digit we just removed from the second call. So that means when we call recursively, I have to pass in, it was x, right? So when I call recursively, I have to pass in x by 10, x divided by 10 with the same function name. So it eventually becomes 0 or something. So let's see how did she try to do this. We gotta follow her structure. So if part A return false, okay, and part B return true. So these two are the base cases, and this is the recursive case, which we return anyway, part C. Okay, so again, as we described earlier, so when we call recursively, we always do divide by 10, so it gets rid of the last digit. So it eventually becomes 120, 1, 2, 3, 4 to 1, 2, 3 to 12 to 1. And you can think of a single digit is the base case because if I don't have any digit, then how can I even check if a digit exists or not? So for the recursive case, we're gonna do divide by 10 for the x portion. And so which I can see that part C is the recursive case. So let me just fill up the part C for now. Part C is gonna be the same function, right? This is the recursive portion. Same function, which is contains digit. Contains, hopefully it's not too small. Nobody's complaining, so I'm assuming everybody can see it. So contains digit, but instead of passing in x and d, this is the original call, I'm gonna pass in x divide by 10. So 1, 2, 3 becomes obviously if you divide by 10, this becomes that, right? And then if you divide by 10 one more time, this becomes that, and then so on. So that's the answer for part C because well, yes, it is about answer for part C. We just call the same function except we just pass in the smaller input. And what is part A and B? A and B are the two base cases. Why there are two? Because when they're single digit long, I need to check. Actually, let me think. Because when they're single digit long, I have to check does this number exist or not. So, for example, if I called contains digit with 1 and 1, this should give me true value. But contains digit with 2 and 1 gives me a false value. That means when they're one digit long, I have to check is x equal to d. If they are, then return true. If they're not, then return false. So in other words, part A is where we return false. That means x is not equal to d, right? In this case, this is the x here, this is the d here. So I say for part A, it's when if part A, so if my x is not equal to d, then we return false, right? Because when they're single digit long, they either can be equal or not equal. And if they're equal, then we have the same number. If they're not equal, then we don't have the same number. So that becomes that x is not equal to d, and the part B is saying when you return true. Return true is this case, right? When they are equal, x is equal to d. So we can return true. So I'll just write down part B is when x equal to d. But I'm a bit confused. How are we gonna build it back up? Let's do an example. So let's do an example. So let me just write down the code first. So it was x equal to, no, not equal to d. And then this is when x equal to d. And part C, I said is going to be contains digit with this. That. Okay, so let's do one of the examples. Let's see if it does actually what I wanted to do. So let's say I initially called contains digit with 1, 2, 3, and 2. This should be returning true, right? That's the expected output. So now we'll go to this line. X is x equal to d. Obviously, they're not. Their x is way larger than d. Well, no. No. So then in that case, I have to make sure that x is 1 digit long. Only then I check. Because otherwise, if I don't make sure it's 1 digit long, then this guy is true actually. This guy is true when I pass in this value. So it's not gonna even go underneath. So I have to make sure they're 1 digit long and then check. In other words, I have to do this guy. If x is less than 10 and x is not equal to d, that's my base case. Similarly, for the other case, I have to put that. So x is less than 10 and then x equal to d. Because if they're not 1 digit long, we are not going to do anything for it. So let me just actually put them in the answer. And that. And that. So it's a 1 digit long. So obviously this guy is not true because then x is not 1 digit long. Also this guy is not true. So you're gonna call contains digit with this guy. So contains, actually this is not gonna work out because in that case it's only gonna check the leftmost digit equal to this guy or not. Oh, so we can what if I check? Okay, I see. Okay. I think I know the answer actually. Let's just do this and let's try to verify it. So it's gonna be this or x mod 10 equal d. Okay, let's try this example and let's see if it does what I wanted to do. So still this condition is false, this condition is false. Then we go to the return statement. Return statement says call the same function but smaller input. So call contains digit with 12 and 2. And then we also need to check this guy. Now, why did I add that, right? So if I didn't add that, just imagine this guy is not there, right? So let's just move on to this example. So now I'm in this function call. So now this guy is also false because x is not less than 10, x is more than 10. Similarly, this guy is also false because x is not less than 10. So you're gonna do this guy again. So now this guy is gonna give me contains digit with 1 and 2. And this guy is not there, right? We're gonna assume this is not part of the answer. So now this guy is gonna go through it one more time, but now x is less than 10 and x is not equal to d, right? Because x is less than 10 here and 1 is not equal to 2. That means this condition is true, so you can return false. That means this guy returned me false. That means this guy also returned me false. That means this guy also returned me false because they're all the one line return statement, right? But I said this guy should return me true because the expected output is true. Now, why that happened is because when I cut off digits, like when I cut off this digit and then I cut off this digit, I didn't check are those digits I'm cutting off part of the answer. Like for example, on this function call, I cut off this digit and I move on to next function call. But when I cut off this digit, the digit I cut off was actually equal to the answer I'm looking for. So that means even though CD of 1, 2 is supposed to return me false, this is a valid answer. This is not a valid answer because CD of 12 and 2 should give me a true value because this 2 is actually part of this 2. That means I have to add this extra condition checking the digit I'm cutting off. Is that digit equal to my digit I'm looking for? If they are, then this is going to be return me false. This is going to return me true. But what is or statement does? Or statement only checks is one of them equal to true. If one of them equal to true, the result is true. Since in that function call, the one I'm trying to draw here, this guy, in this guy, there is two parts, right? This is the first part and this is the second part. First part is going to give me false value, right? Obviously, when I come back from here to here, this guy gave me false value. But this guy is going to give me true value. Why? X mod 10 in this part, CD of 12 and 2, X mod 10 was 2, right? This is my X, this is my D. So X mod 10 is the value 2, but this 2 is actually equal to the digit I'm looking for. So since they are equal, so this becomes false or true. But in the Boolean statement, if the OR statement connected with two Boolean values and one of them is true, the answer is true. That means this guy is not gonna give me a false value, this is gonna give me a true value. And since this guy is giving me a true value, when I go back up one more time in the recursive call, it's getting messy, but I hope you guys are understanding what's going on, what I'm trying to explain here. When I go back the last time, it's becoming like this: CD of 1, 2, 3, sorry, 1, 2, 3, and 2. And this guy's gonna return CD of 12 and 2, or is 3 x mod 10, right? X mod 10 equal to 2. So now this part alone is my 3, right? Because right now x is 123 and x mod 10 is 3. This guy is false. This part is false. But this guy gave me true value, right? Because, when I did this guy. Again, if I do this operation, return true or false, it's always going to give me a true value because one of them is true. And that's why the actual answer gives me true, and that's what I was expecting in the first place. Okay, so that's why I added this last line of code at the end. And that's actually the whole code for this function call. Any questions so far for this part? So let me just make the changes for the answer. It's going to be this or x mod 10 equal D. Also, I'm assuming there are multiple ways to solve it. This is just one way to solve it. I don't have the answer keys. I don't know how Professor Chyn actually solved it in her own way. That could be different. If that's better for you to understand, that's completely fine. But this is just one way to do it. Okay, if you don't have any questions for this part, then I'll move on to the next function, which is the remove duplicates. Let me just clear things out.
I have a question.
Yeah, go ahead.
Yeah, for so the whole idea of of the first two base cases just it's all focusing on like what the last digit is.
Yes,
Okay.
not the last digit. It's just when they're one digit long, because everything
Okay.
has to reach base case somehow, right? What's
Yeah.
the base case, right? Any big number, if I do divide by 10 long enough, it's gonna reach one digit case.
Oh yeah, if it's one digit then there's nothing there's
Yeah,
no
if they're one
duplicates.
digit, then we can just
Okay.
check are they equal or not.
Oh yeah, because
Because
I
we know
did
digit
my
is one
base
digit
case a little
long.
different.
Exactly, yeah. Because it already said digit is gonna be an integer between 0 and 9. So
Yeah, so I
D
did
is also
my
one digit.
base case a little different. So what I did was like if x is less than 1 or if d is less than 0 or if d is greater than 9. So I was making that based off of what they were saying here about the second parameter being an integer between 0 and 9.
Well, that part basically says is say just a one digit. It can either be 0, it can be 1, it can be 2, it can be anywhere up to 9, like any one of these numbers.
Hmm.
Now x can be anything. X can be 1, 2, 3, 1, 2, 4, 1, 3. It can be like 1 million digit long for
Okay,
what matters, right?
so you should make the base case more towards like how the function's gonna end.
Exactly, yes.
Okay, okay.
Perfect, yes. Yeah.
Hmm.
Okay, so if that is more clear, then I'll move on to the next part. Okay. Someone tried to join. I think Lauren is adding them, so I don't have to worry about that. So next part is saying, so we did part A, we did part B, we did part C. Part D is, where's part D? Part D is this guy. Okay. So now we're doing remove duplicates. And what was the idea for remove duplicates? It is removing, so if I just zoom in, if it's removing this, so it's only keeping the leftmost occurrence. So that means this guy is removed, this 1 is removed because there is a left 1 here. This 2 is also removed, and this 3 is also removed. So the answer becomes 1, 2, 3, 4. So let's see how did she try to do it. So her base case is where these two. The first base case is when x is less than 10. Okay, we return x. Yeah, that makes sense because if we call remove duplicates with 1, the answer should be 1, right? There's nothing to remove anyway. There's only one digit. This one makes sense. The next part says, oh, now we call the function we just made in the previous section. So now we say is if contains digit of, okay, what's going on? So it's, in other words, if I call remove duplicates with, I don't know, 1, 1, 2, 3, 2, 4, was it 3? Okay. If I call it like that, then this line of code is checking if contains digit with this part is x by 10, getting rid of the last digit. So 1, 1, 2, 3, 2, 4, and this part is 3 because that is the last digit. Okay, so if they are true, if this part has the last digit, what am I gonna do? I should not include it to my answer, right? Because when I didn't include the 3, this 3 was not included to my answer because there was a 3 beforehand. So in other words, her idea here was, if this guy is true, if this orange box is true, that means there was a 3 one more time into this number, the number accepting the last digit, right? If that is true, then I should not include the 3 on my answer, right? That means the answer should be returning 1, 1, 2, 3, 2, 4. Right? Even though my function had a 3 at the end, I did not include the 3 because that 3 already existed in the previous portion because the contains digit gave me a true value. That was the idea here, right? Since we know what she was trying to do here, I can just quickly write down the part D. Part D is saying if that x mod 10 exists somewhere in the previous portion, we don't include that. So I can just return x divided by 10. Right? Because x divided by 10 was the portion excluding the last value. Okay. So this is okay. So the indexing is a bit off. Not sure if that was the actual indexing for the question, but technically this is the part of the if condition and this part is the outside of the if condition. So this part is gonna run anyway. So I'm assuming this is the recursive call because there is no condition to check for this case. So recursive call is gonna become, I'm assuming, just x divided by 10 because every time we see a number, almost all the time when you call it recursively, you just do x divided by 10 as the input because that will give you a smaller input than what we had originally. And we can try an example to make sure that works or not. So I'll do same function name, which is remove duplicate because we're calling it recursively. And we're gonna pass in x by 10. Okay, so now let's try an example to make sure if that works or not. So let me clear things up. Spoiler alert, if you are gonna be taking 316 with Professor Kong, this part is something this professor teaches, how to remove duplicates. And that's also a different language called Lisp. This is just, further topics you need to worry about that for now. So let me try out my example to see if that works or not. So I said this is gonna be my part D. So let's put it on part D. Oh, the return is already there, so I don't have to put return here. So let's not put return here. And part E is this guy. Okay. Okay, let's try an example. So let's do a simple, smaller input so I don't need to waste too much time. Let's do 1, 2, 2, 1, 2, 3, 2, 3. what should be the output? The output should be 1, 2, 3, right? Because this 2 is ignored because there is a 2 beforehand. This 3 is ignored because there's a 3 beforehand. So let's try to see if that's the case in our code. So we do remove duplicates of this function. The first condition is false because x is not less than 10, so we don't do this portion. Second line of code does if contains digit, so we're gonna call contains digit with x divided by 10. So I'm gonna call it 1, 2, 3, 1, 2, 3, 2. We don't include the 3 because we divide by 10, get rid of the last digit, and we do x mod 10. X mod 10 is the 3. So now is this condition true? Obviously, this guy is gonna return me true value, right? Because 3 do exist in this number as we did earlier. Since this is true, we're gonna return x divided by 10. So this guy should return oh, it should be return remove duplicates of no, what? Then it's the same case anyway. Let me think. Because I still need to remove the 2 here. I cannot just return the value right away. But if I do remove duplicates here, so I also remove that value. If I do it like this, then it's the same case anyway, so what's the point? Oh, I think I know what's going on. So it's gonna be, oh, this one times 10 plus the last digit. Oh, I see. Okay. So what was the problem? The problem was if I just do it like this function is gonna return me 1, 2, 3, 2 because that was the x divided by 10, and that's the output of this function right away. We didn't even go to this portion, right? Because contains digit was true. 3 was part of this number. So we return that value. Obviously, we cannot return that value because I still need to remove the 2 here, right? That means I cannot return here right away. I have to return the answer of remove duplicate of that value. That means I also need to remove some other values because we don't know if every duplicate is removed or not. So I cannot return the value right away. I have to return the the return should be outside. What am I doing here? Return should be outside the function name. So return that. So basically return the value of that guy. But now this part, I had originally this line, right? I originally had this as my answer. So I told you that this is the recursive case. Recursive case meaning this guy runs anyway. This guy runs whatever x was. If this one was false, this one was false, this guy will run. That means this part is actually the else condition of the previous if statement. You can think of it like this: if that and else that, right? Else was not there because in C++, if you return right away, we don't go to the next part of the code, so it automatically skip that portion. But in that case, it's saying that this number I was checking is not part of this number. This number I am trying to point at. What does that mean? For example, if I have 1, 2, 3, and 4, and in contains duplicate contains digit, I think that was the called. The contains digit. That means 4 is not part of that number. So in my actual function, which is remove duplicate, I should include, like it was 1, 2, 3, 4, right? In that test case, I said 4 is not part of this number. That means in my actual answer, I should include the 4, right? That means when this guy is false, I have to somehow include the mod 10 to my answer. And how do we do that? The idea is this. We still need to call a smaller input. Like this part is still true, x divided by 10, because that's only gonna give you a smaller input. But I also need to add the digit I didn't include in my recursive call. And how do I add a digit? I just times it by 10 and add the last digit. And you will see what actually goes on in this portion. So add the last digit, which is x mod 10. Basically, timesing it by 10 pads an extra 0 at the end. In other words, if I have 1, 2, 3 as my answer and times it by 10, that basically gives you the same number and add an extra zero at the end. And when I add an extra zero at the end, I can just change the zero based on what was the last digit I didn't include, right? Which was this portion, x mod 10. So x mod 10 gives you the last digit I didn't include, which was 4 in this case. And once I get the result, for example, the result is 123, I time it by 10 to add an extra digit, and then add the last digit, and I get 1, 2, 3, 4 as originally. So that's why I had to do this portion.
Okay,
Uh,
so I have a question. So,
yeah.
um, so basically, after we remove the duplicate, we're just adding back the leftmost number back in.
Yes. Yes.
Okay.
Only when this condition is false. So for example, this guy didn't have the plus x mod 10, but this
Mm-hmm.
guy had plus x mod 10 because this condition was true. That means the mod 10 is part of this number, right? In this
Mm-hmm.
case, right? In this case, this mod 10 was part of that number. So I didn't include the mod 10, right?
Yeah.
Like I didn't do mod 10 to this if condition. But since this condition failed, that means the else condition, which is this case where the mod 10 is not part of the number, so we can include that number. How to include the number is like what I did here. Time it by 10 and add the last digit.
Okay.
Okay.
Mm-hmm.
So that's the answer. I'm pretty sure, unless I made some small mistakes here and there. Again, you're not supposed to come up with the answer right away. Right, just looking at the question or figuring out the answer. Oh, hey, I already know the answer. Like even for me, I had to go through it. I did my initial answer was wrong, right? How did I know my answer was wrong? When I did a test case, I realized that my code is not doing what it's supposed to do. So I had to make some changes. And obviously, you can write in pencil and, remove stuff and make some changes in your actual exam. So just do that. When you're finished writing code, just make sure that works by running a test case, like, make up some number, and checking if this return me the correct value, like is this guy the correct value. If it is, then we're good to go. If they're not, then you might have made some mistakes. So just figure out what's going on. Also, I was confused, like if I don't do this portion, right? If I don't include that portion, then these both cases are same, right? They're the same line of code. So what's the difference of adding an if condition beforehand? So there must have been something different between these two test cases or these two return cases. And that's why it clicked that, oh, hey, I didn't include the last digit on this portion. And how to include the last digit is by like that. Okay, so that is the recursion example of recursion. Hopefully that was making sense to y'all. So we were gonna move on to a different topic. Let's see what other topics she had. So we did recursion, we did title line, we did this guy. We can do one array. Pattern printing. Hopefully I'll have time, but if I don't have time, this is part of exam one, and I'm pretty sure there was an exam one review sessions from Professor Chyn, and there's also that's already posted on YouTube channel. So you can just look up the video and look up the pattern printing portion of that review session. But we're gonna go back to pattern printing at the end if we have time. Let's just go over one of the array function type of questions. If you guys have any particular question from array you want me to go over, just send it in the chat. Otherwise, I'll pick something on random. Okay, I'll pick something from 2D array because that seems more complicated than 1D array. I'm not sure if Professor Chin covered 2D array. If he didn't, just let me know so I don't pick a 2D array question before I start. But this one is very easy. Let me find a different example. Okay, we can do this one. I don't know. Okay, so I picked a random question from the list. So this question is saying, write a function. Also, I'm not sure if Professor Chin gives a question like this, where you have to write the full function, or she does something like this, where she gives you part of the code and you have to fill up the gaps or part A, B, C, D, E. Either way, you should know like how to write it from the scratch. So if you can write from the scratch, you can figure out the empty spots. So this function is saying, write a function called percent positive that returns percentage of entries in a two-dimensional array with 4 columns, okay, that are positive. Excessively long solutions, this is just a, this is nothing to worry about. For example, the program, okay, so this is an example. So if the array is like that, and you call the function percent positive, these two numbers are basically the sizes. 2 is the number of rows, 4 is the number of columns. How many numbers are positive? This number is positive. Only one number is positive, right? So in other words, 1 out of 8 is positive, and that is, I think, 12.5%. So it prints out 12.5. Actually, it's actually much easier than what I thought. But anyway, we can just do this quickly. So let's start writing the function. So percent positive. How many parameters does it take? It takes 3 parameters, right? X, 2, and 4. First one is a array of type double. X is a type double array. It's a 2D array also. So double 2D X. I can call it X. You can call it A. You can call it B. Doesn't really matter. And then two integer values, right? So I'll call it int A and int B. Um, Usually for the array questions, these two values are almost always the size of the array. So 2 is the number of rows and 4 is the number of columns. So usually people write down, variable name as row and column. So it makes more sense to the person who's reading the code. And what does it return? It returns this number, right? 12.5, because it's saying it's going to print 12.5%. Percent is already given in this portion. So the output or return type is basically 12.5. What is 12.5? It's also type double. So I'll just put a double for the return value. So now moving on to the body of the function. If you guys don't know how to iterate over an array, is say it's with a for loop. Similar to iterating over strings or anything like that. You have to go over every item one by one. So in this case, let me just quickly write down the thing. So I have 1, -1, -2, -3, and then I have -4, -5, -6, -7. So the column always start from 0, as always, and these are 0 and 1. Okay, so how do we iterate over an array? You have to, for 2D array, you need two nested for loops. One loop going this direction and another loop going top to bottom, right? Let me just move it a bit here. Another loop going this direction. Obviously, you usually go from row, and you always start from row. So the first value you want to look at is this guy. Second value is this guy. Third value is this guy. Fourth value is this guy. And then you come back to this portion. So in other words, we go from 0, 0 to 0, 1 to 0, 2 to 0, 3. And then I go to 1, 0, and then 1, 1, and then 1, 2, and then 1, 3. So in other words, let me write down the for loops. So we start from 0 all the time for arrays. And this is going to be my row, the loop for the row. So I'll do row here, because this row is basically the variable row on the parameter, right? And I'll have another loop for the columns. So int j, you have to make them different also. Don't make I here and then I here. Don't make that mistakes. J equal to 0, j less than column, and then j plus plus. So this loop ends here. and this loop ends here. So if you just do it, it will do exactly what I did here. It will go from 0, 0 to 0, 1 to 0, 2 to 0, 3. And then this loop will end because there's nothing after the 3. And column value is 4 here. When j becomes 4, this condition is false because 4 is not less than 4 anymore. So we go back up, we update this pointer. So this pointer becomes I equal to 1. And then we do 1, 0, 1, 1, 1, 2, and 1, 3. So what's the idea here? Idea here is to count how many number are in the array is positive, and basically do the operation we did, right? It was 1 divided by 8, and that gave me the value 12.5%. Right? Actually, going to give me 0.125, but you can figure it out. So in other words, I'll make some kind of variable in the outside of the for loop. Why? Because I need to make sure that how many numbers are positive. So I'll call it number of positives. Very big variable name. You can call it as small as A, B, C, D, E, right? You can make this a variable A. A doesn't really matter. I just made a different broad variable name. You know that what this variable is doing here. So this is going to count how many values are positive, and how can we check if a number is positive or not? Well, I first access the value. Accessing the value is always access ij. I is the row, and going to that row, j is the pointer, or j is the column of that pointer of that column. So ij gives you the actual value, and I can just check, is this number greater than 0? If it is, then this number I just saw is a positive number. That means this variable I just made, I can update the variable with plus plus, meaning I just had one more positive value. If the next number is also positive, it's going to do plus plus again. So at the end, when the loop ends, the both loop ends, the number of positives will have the amount of values who are positive number. So then I can just figure out some math to figure out how can we return 12.5. So obviously, now you say, for example, number of positives in this case is gonna be 1 at the end, because there's only one values in the entire array that's positive. So I will do 1 divided by the size, right? Where did I get the 8 from? 8 is the size, which is like 2 times 4, the entire amount of the array, how many items are there. So I will do 1 divided by 8. That is going to give me, I think, 0.125. And then you have to times it by 100 to get 12.5. So in other words, what I just did the math here, right? It's going to be like this: number of positives divided by the size, or the entire how many numbers are there. In other words, there is row times column. This is how many values in total. Then this number is going to give me 0.125, because 1 divided by 8 is 0.125. I got to multiply it by 100 to get the 12.5, right? Because that's what they want here. And that is the value I want to return. So I can just return that value right away. Return that number. Okay. And that's actually the entire code, if you didn't realize it. Nothing too crazy going on. Just basically counting how many numbers are positive, and then doing some math to figure out how to get the number they're looking for, which is 12.5 here. Okay. Simple enough. Hopefully now, if you have any questions on this part, then I will be moving on to a different topics, I guess. Pattern printing and function implementation for string. Let's do this guy first. String function implementation with strings. Hopefully you guys covered strings, as someone mentioned in the beginning of the call. So let me just pick a question on the random, unless you guys have something you want me to go over for string problems.
I would like to go over the one at problem 15. I'll paste it right into the chat.
Sure, that'd be great. Thank you. Wait, by the way, Lauren, are you also recording? I'm already doing it.
I think it's through the cloud recording. It says on my end that it is recording and it'll go through the Learning Commons.
Oh, okay. I thought like both of us are recording 2 times.
Yeah, I think it only goes once.
Okay, good to know. Okay, this is like a pattern printing problem, but yeah, we can do that. Okay, so someone pasted this problem. Write a program that does this. Positive integer. Okay, if the user gives. Okay, so there's some cases, right? It has to be positive first. If the user gives a non-positive value, it should terminate immediately, meaning return 0, right? Return 0 terminates the program. Otherwise, the program should print a upside down triangle, like that's given here. And the example is here. The triangle should be made with X's and blank symbols. One with periods per row. It should be blanks. Okay, I see. I mean, this is just like in words explaining what the pattern should look like. But there's space, right? Triangle should maybe. Oh, there's a space. Okay. So there are space in between the axes. Okay, so that's good to know. So, sure, we can do that. Okay, so let's start the coding. This is the complete program, so I'm assuming you have to write everything, starting from include iostream, include IO stream, and I think it's called namespace std, space std. Um, this is just a library called input output stream, and this is also I don't know what this is actually. Namespace is something you can search it up if you want, but nothing to worry about for this class. Okay, so now we have the structure done. So first things first, um, reads a positive number from the user. So I have to ask the user for a number. Cout enter a number, and then the user will input some kind of number, right? And I have to store that number somewhere. So cin, I have to store it somewhere. In the question they said the number should be called n, so I'll make a variable called n. And I will store whatever the user inputs into this variable with the cin. In other words, console input. Then it said if the, where is that? If it's a non-positive value, then we should terminate immediately. In other words, we can just check if this number is positive or not, right? If it's not positive, that means if n is less than 1, I'm assuming 0 is not counted as a positive value, right? The smallest positive is 1. So if the user inputs 0, it should still terminate. So I can just check if n is less than 1 or n is less than or equal to 0, both of them are correct. We should just terminate the program by calling return 0. Okay. So then if they're not, then we move on to the printing portion. Otherwise, we print like this, right? So what's actually going on here? If you just look carefully, there are spaces in between. So there is like one X, then one space, another X, another space, another X, another space, another X. And I'm also assuming there's also space afterwards, which you can't see because it's space anyway. Why they say that? Because for the number 4, there are 8 values in this line. 4 of them are X's and 4 of them are spaces. So X space, X space, X space, X space. For this line, there are 6 values, right? X space, X space, X space. And there are 4 values here, and there are 2 values here. One of them is X, other one is space. So obviously to print this pattern, I have to run a for loop going into this direction, another for loop going to this direction. In other words, it's a nested for loop like we did for the other question. So let's start with the for loops first. Int I equal to 0. I usually always start from 0 For pattern question, you can start from anywhere. It doesn't really matter. It's just how many iterations does it take. So, in this direction, I should iterate 4 times. And to this direction, I should iterate 8 times, right? Because every row has at most a value. Technically, they're all space. Like if you think about it, from here on out, everything here is space, which you can't see, obviously. And if you write something that has space, it will not cut points off because it's still gonna print out the same pattern they're looking for. Okay, so it's gonna run 8 times on the horizontal direction and 4 times in the vertical direction. So usually the first loop is the vertical portion, so I'll just do I less than 4. Not 4, it's actually less than n because 4 is the value the user inputted, right? Which is like kind of here. You can't really see it. But 4 is the value user inputted. That means this is actually the value n, and that is the value 2n, or 2 times n, I should say. So my first value will run n times I plus plus, and my second for loop int j equals 0, j less, it will run 2n times, so 2 times n. I just don't trust the order of operations, so I just always put parentheses before and after. Like I'm not sure what will happen if I do it like this. Is it gonna check j less than 2, or is it gonna check j less than 2 times n? So just to be clear, I always put parentheses before and after. So then we do j plus plus. So this loop ends here, and then this loop ends somewhere here. Okay, so what is it? Ignore. Okay, so when do we print access and when do you print spaces, right? That's the goal. The first goal here is to figuring out that what is this line, because everything before this line is having some access and some spaces, and everything after this line is strictly spaces. So this value is, let me just do the example here so I can draw x, 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 then x, 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 x. So this is 0, 1, 2, 3. This is 0, 1, 2, 3, 4, 5, 6, 7. Okay, so hmm, so this value is 0 plus 7. This value is 4 plus 1. This is 7. This is 5. This is 3. Interesting. And this is 6 actually. 0 plus 6 is 6. This is 1 plus 4, which is 5. So for this value, the I is 0, j is 6. So I plus j gives me 6. But for this value, I is 1, j is 4, right? 1 and 4. I plus j gives me 5. But I also want to know I plus j. It's decreasing by 1. I see that. So is it I plus j plus 1 plus I? So if I write this condition, I plus j plus I less than equal to n 2n is 8, 8 minus 2. Is this the condition for the diagonal? Let's try. If Lauren knows, could you figure this out if I can't? I hate pattern problems like a lot. So for the first line, this portion is, or let's just do this the edge cases. So on the edge case, I is 0, j is 6, I is 0, total is 6, total is 6, less than or equal to 2 times n. 2 times n is 8, 8 minus 2 is also 6. This condition is true. Okay, good to know. How about this guy? For this guy, I is 0 and j is 4. So 0 plus 4 plus 0 less than equal to, this is always 6 actually, which is true. In other words, this condition might be the condition for just the diagonal. If they're equal, then they're exactly in the diagonal. If they're less, then that means they're on the left side of the diagonal. If they're greater than, then we're the right side of the diagonal. So in order to print x's, this box condition has to be true. We can verify it with online compiler at the end. But let's see. So if this condition is true, so let me write down the condition first. If what did I write? I plus j plus I. Why did I do all that? How did I figure this out? Another question. So usually for diagonal is something like row plus column, right? But now, once I do I plus j, I realize that I plus j gives me 0 plus 6 for the very top right portion, right? Which is 6, right? But n is 4. In other words, 2n is 8. So that means this value has to be less than 8 minus 2. If I just say 8, that means the 7th value is good, right? This guy is good. But I don't want a x here. I don't want a x here. I want a space. So that means it has to be 8 minus 2. In other words, 0 plus 6 has to be less than or equal to 6. Only then we print a x. And that's how I figured this out. But once I realize the next position is not 6 anymore. This guy is 1 plus 4, which is 5. So 0 plus, I plus j gives you 1 plus 4 for this guy, right? 1 plus 4. This guy is obviously, less than or equal to 6 in general. But then for the next guy, the 5th position, I do not want an x here. But if I do 1 plus 5, it's still true though. This is true, but I don't want an x here. In other words, this cannot be like just 1 plus 4. There has to be something else. In other words, you can just say plus I here or minus I here. Both of them works. In the first case, I is 0. So minus I still gives you, whatever that is. I just did plus I here, but if I do this also works. Minus I basically, subtracts 1 every time. So 0, first term, subtract 0. Second term, subtract 1. So for the second condition, we're checking is 1 plus 4 less than or equal to 2 times 4 minus 2 minus 1. Because for second term, I is equal to 1 here. If I do the condition, this is 5 less than or equal to, this is 8 minus 2 minus 1, which is true, right? 5 is less than or equal to 5. So that's how I figure out this condition. So let me just quickly write it down. What I'm afraid of is it might be not right. 2 times n minus 2 minus I. This condition has to be true in order to print an x. First things first. But there are other conditions, right? Like for example, we don't print x here. We don't print x here. We print spaces. So we have to figure out how to get those values. So let's do this, 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 and this. So when do we print the x? We print the x when these values are even, right? If this is even, print the x. This is odd, do not print the x here. This is all empty. This is an even, print the x. This is odd, 3 is odd, do not print anywhere here. This is even, print x. This is odd, do not print anything here. In other words, there's another condition to check is, so what is this pointer again? This pointer is I, this pointer is j. I also need to make sure that j value is even. How do I make sure it's even or not? It's always mod 2. Because mod 2 gives you only the values between 0 and 1. 0 meaning the number is even, 1 meaning the number is odd. If I put j here, I have to check is j mod 2 equal to 0 or not. If it is 0, that means j is even, and if it's even, I can print the x safely because all the even indexes have an x, right? 8 doesn't even exist, so I don't need to look at 8, so we're good to go. Also 0 mod 0 is also 0 mod 2 is also 0, so we are also good to go. So in other words, this condition has to be true, and another condition has to be true. So let me just make them just a bit spaced so you know what's going on. This condition has to be true, and j has to be even. Other words, j mod 2 has to be 0. If this entire thing is true, right, this condition being true and that condition being true, then we can safely print out a x. Otherwise, which is the else condition, we print a space. Okay.
I have a
Also,
question.
yeah, go ahead.
So yeah, I had the same layout, but I didn't really figure out like the
Like
condition the same.
this
Yeah,
condition.
like I had like the condition be like R plus C mod 2 equals 0. So like R when the rows and columns add together is even, that's when it prints an X. But I wasn't
Yeah. So, like for
sure,
example,
and then I'll do like else C out space. That's what I did.
yeah. I mean, you are almost correct. Only part was like there are some even cases here, right?
Okay.
Like for example, 2 plus 6 is even. Like this case is even. This is 2 and this is 6, but we do not print
Oh,
an X
okay.
here, right? When you say something like triangle, like upside down triangle or something like that, it always you gotta make sure where the diagonal is. Like what is the equation for the diagonal? And I just
Mm-hmm.
figured it out first. Once you figure out the diagonal, you just do less than, greater than, whatever it needs, right? If the diagonal is not included, like for example, if n equal to 4 prints out x, 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 and then this is index 0, this is index 2, index 3, 0, 1, 2, 3, 4. You get the idea. If this is like that, the diagonal is actually here, right?
Yeah.
The diagonal is not included. In that case, I will not do equal here. I'll just do less than, and
Okay.
that will take care of it. And if I want the other part, if I want this part to be have access, I'll just change the sign. I'll flip the sign here. And the equal sign basically says where the diagonal is true, print out access, like print out x here, print out x here.
Mm-hmm.
That's why I include the equal here. Okay. Pretty sure that's the answer, except we have to do a cout endl after the first for loop ends so that I move on to the next
Okay.
line, right? I'm not exactly sure if this is correct or not, so let me just quickly do it in an online compiler to make sure if my answer is correct. C++ on, I don't think I'm sharing my compiler. Let me stop share first. Then I'll share my entire screen. So, okay. Mm, do that. Hopefully it's right. Run it. Number 4. There you go. Perfect. You guys can see my screen, right? Let me see. Share.
Yes, I see it.
Okay, so I just pasted my solution in compiler and I type 4. It gives me the exact answer I'm looking for. If I run it one more time and type 6, it should give me, oh, why is it? I think it's lagging for some reason. Let me reload the thing. Run it. I'm not sure why that's going on. But anyway, we just saw for the n equal to 4, that prints exactly what we expected. So that should be true for every other test cases. My PC is acting weird. So that's the answer for this question. Hopefully that made sense to you. Again, just finding out where the diagonal is and what's the equation for the diagonal. Almost always, it's always r plus c less than something or greater than something, right? Whatever the something is, you gotta figure it out. Just typing in some test cases and figuring out what this value goes. In our case, it is basically 2 times n minus 2 minus I. Just I know first I did 2 times n, didn't work. Then I did -2, also didn't work. Then I did -I, then that worked. Just trying out, trial and error process. Did that load? It didn't
So
load. I think
actually,
the
wait.
first
So
case, yeah.
what was the purpose of the first check with the less than or equal to?
This guy, this portion,
Oh yeah, yeah, yeah.
that
That
portion
part.
that just make sure there is nothing being printed on this side of the triangle.
Okay.
Like in this side of the triangle, there are some cases where j mod 2 is equal to 0, right?
Mm-hmm.
But I gotta make sure that even though j mod 2 is equal to 0, this condition is false. And if I just include them with the AND operation, true, sorry, false, actually, yeah, false and true, it's gonna give you a false value.
Mm-hmm.
Because for AND, both of them has to be true at the same time.
Yeah.
So just
Okay.
making, yeah,
So that 2 times n minus 2 minus I, that's accounting for that blank portion.
yeah, exactly, yeah,
Okay.
yeah. And I did less than equal to because I want the left side of the diagonal to have access.
Mm-hmm.
And I don't want the right side. The diagonal was included, so I did less than or equal to. If the diagonal was excluded, I'll just do less than, not equal to. Okay. Um, it's just basically just trial and error process. You just type out different stuffs and doing a test case and make sure that your whatever you wrote actually works or not. Um, okay, so we're gonna move on to different topic. We have only 15 minutes left. If you guys have any particular topic you need to cover right now, um, this is the last chance. Otherwise, I'll go over some kind of string because someone said string is part of the final, and we haven't done any string problems yet. So let me quickly find out a string problem. Also, if you guys have to leave early, Lauren, could you send the feedback form one more time?
Yeah, of course.
Feel free to the feedback form. We keep track of that to host more review sessions in the future. Let me know where I did good, where I did bad. I'll just do it before you leave tonight. So let me find out one example for string problems. Okay, let me ask you something here. This was from another professor. So copy that. Okay, people who are in this call, have any of you guys seen anything like this on your on your lectures or something? Did she cover anything like
Yes, I
this?
actually learned that pretty recently.
Okay,
Mm.
so it is
Mm-hmm.
covered. So this is
Yes.
part of Professor Steinberg's 111, and actually his question is very good to cover strings. I'll just go over his question if that makes sense to you. So let me just look up his question, which was yeah, this one. Okay, so copy that. This was the question from Professor Steinberg's 111 review session. So let me just do them side by side. This question uses a multiple functions from this list, so you can get an idea of what to do where. So I will read the question. You can read the question on your in your time. But what it's asking here is to write down this function that is gonna be given here, and it takes some value name as a string like this, and it converts this entire string to this string. And what is the conversion rule here? It takes the first value of the first name, like this O here, correspond to this O here, and it takes the entire last name, right? Entire last name. Only exception is all the small e's gets converted to the threes. The small e here became a three here, and the small e here became a three here, and that's all. And they give you some constraint, oh, hey, at least use at least two different string methods, blah, blah, blah. And you can just use whatever you want here, whichever are necessary, of course. So how can we do this, right? For middle name, they said there's going to be any number of middle names. So it can be 0 middle name, it can be 1 middle name, it can be 300 middle names. We don't really know how many middle names are there. All we know is there's a one first name at least and one last name at least. So the idea here is quite simple actually, if you didn't figure this out yet. It's basically finding out where the spaces are, right? For one middle name at least, there's going to be two spaces. One space between the first name and the middle name, another space between the middle name and the last name. If there are two middle names, there's going to be three spaces. So imagine there's another part of the name here. So that is actually the last name. That means this Steinberg is a middle name. So there are three spaces like here, here, and here. In other words, if you can somehow find out where the first space is, everything beforehand is my first name. Similarly, if you can somehow find out where the last space is, everything after it is my last name. So once I can find out where the first name and the last name is, then I can do some string methods to get this value I'm looking for, right? So let's quickly get into it. So I have to somehow find the first space, find the last space. That's the primary goal here. So how to find the first space? Obviously, there are functions for that, like these functions. Find function finds a value, a target value. I can just say the target is space, right? Similarly, rfind, in other words, right find, finds a value from the right side. So regular find finds a value going from left to right, in usual, in this direction. And rfind, which is the right find, goes from right to left and look for the first target value. So you can use those to find the first space and the last space. So to find the first space, I can just say the string variable is called name, right? That's the variable they call it. So we can say name dot find. It's a small name, sorry. And I'm gonna pass in a space. That's where the first space lives. Now this is gonna give me the index of that value. So I have to store that index somewhere. So I can just say int first space is equal to that. So that means wherever the first space is going to be stored in this variable called first space. Similarly, for the last space, I'm going to do the same thing. Last space equal to name dot. Now I'm going to use rfind because I want a space from the right side or the first space from the right side, like that. So this is the last space is gonna store the last index. So if I just count properly, let me do red. This is index 0, index 1, index 2, index 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So first space is at index 4, and the last space is at index 12 in this example. Okay. So this guy is gonna store me the value 4, and this guy is gonna store me the value 12 here. Okay, so how can we get everything from 0 to 3? That's the first name, right? Now we're gonna use some other string methods. So this method, substring, which is very important in general in comp sci, substring is a very important topic. It basically picks picks something from the string, right? You can call substring two ways. One way is passing in one parameter, other way is passing in two parameters. This parameter is when you want to specify how many characters you are picking or the amount of characters you're picking. And this parameter doesn't have any amount. That means going from that index onwards, everything is everything's going to be included on the substring. And you will see what I mean when I do this example, because we're going to use both of those substring methods for this problem. So first of all, I got to find out the first name is. So I know the first name always starts from index 0 because index 0 is where the string starts. Now, how much do I go? I cannot just go the entire part, because the entire part includes first name, last name, middle name, everything. I have to stop somewhere. I have to stop at index 3, because that is the last part of the first name. How can we do this? I don't know why it's doing it. How can we do this? It's just basically this number 4 is telling you, in other way, that this is how many characters are there for the first name. If the space was at index 5, then the first name has 5 characters, 0 through 4. In other words, if I just do this line of code, name dot substring, start from index 0, obviously, and do first space. This will give me actually the first name. Starting from 0, go that many characters, or take that many characters, or the amount in the example they gave you. And first space is actually holding me how many characters are there on the first name. So since this guy gives me the first name, I can store this value somewhere. So I can just say string first name equal to that. That's going to give me the first name. Now we're going to do something similar for the last name, but last name. So what do I do for the last name? I know the index last space have the value 12, right? So I have to start from 12, obviously. Actually, I have to start from 13 because 12 is not part of the last name. 13 is the part of the last name, right? 13 is the S here. 12 is the space. We don't want to include the space on the string. So I have to start from 12 to 13. How do I go to 13? It's basically last space plus 1. Subster last space plus 1, because that will give me the 13th character to start with. Now you can figure out how many characters to take from 13th position. But again, did you see the substring method, the first one I said in originally, the one where you don't include how many characters, like this guy says going into that index, take everything after that. And actually that's exactly what I want, right? Going from index 13, I don't really need to know how many items are there, because everything after that is part of my last name anyway. So I can just use that as my only parameter and close the parenthesis. That will actually give me index 13 onwards, everything after that. And that's exactly what I want here, right? I want the entire last name to be outed. And that's exactly how we do it. Okay. If you guys are confused by something, just let me know. Otherwise I'm not, if I'm not making sense, obviously. So now that we have the first name and the last name, then I can just figure out how to do this guy, the answer I'm looking for, which is the first character from the first name and the entire last name with the E replaced by the 3s. So first character of the first name is basically first name at 0, because strings are arrays of characters, right? The string ON, you can think of this as a array of characters. The first character is at index 0, second character is at index 1, index 2, index 3. If I just want this value, I can just say this is the name, right? This is the first name. First name. If I just want the O, I can just say first name at 0. This will give me the O. Okay. So there is that. Then I also need the last name, the entire last name actually. So I'll just add plus basically concatenate one with the other. I'll add the entire last name, and that should be my conversion, because we don't, if you see the example or the title line, this is the void function. So we don't return this value. What do we do? It says in the question, it converts, right? It says in the question. It basically converts the name, which was originally the entire name, to this guy, meaning we want the name after the function ends to be like this. The name should be converted to first name at 0 plus the last name. And that will do it. And also the hint here is the pass by reference here. In other words, that basically tells you that the name, which was originally a full name, including first name, middle name, last name, will be converted to this username.
I have a question.
Yeah, go ahead.
Yeah, okay. So to get that original string to look like that, we're doing wait, like I thought because I thought we were gonna use like the replace method and like we're just gonna
Yeah, we haven't
change
done the
things,
E
right?
portion yet. Yeah, we haven't done that
Okay.
portion yet. I skipped that portion for now.
Oh,
Yeah, yeah.
okay.
Yeah, I haven't changed the E's to 3s yet. But I'll do it right now so you guys know what's going on. So I have to change the E to a 3.
So what was
So
the purpose of that last line of code?
that line of code basically changes the name, which was originally this Oren space Stanley space Steinberg, to
Okay.
this guy. And this guy is basically C plus the Steinberg portion.
Okay.
So I didn't do the E to 3 yet, so I'm gonna do right now. So basically this guy, the last name has the value Steinberg, right? As Teinberg. I want this to convert it to threes. Or every time I say E, I have to convert to 3. Again, it's a string, and I said string is a array of characters. How do we iterate an array? With a for loop, right? So I'll run a for loop.
Okay, so we're creating a for loop and we're gonna check for the e's. Okay.
Exactly, yes.
Mhm.
So I equal to 0, and string also gives you this method called a length or size, which basically tells you how many characters are there. So I'll do name dot length I plus plus. They're all zero based index, so I start from 0. And I just gotta change if the value is E. So if name sub I is equal to E, that's where I replace them. I replace with a different value. And there's a replace method given, right? Which is this guy. So you can kind of like memorize this portion. Um, the function basically does what the name suggests, right? Length finds the length, find something, find which is the right finds from the right side, replaces something, substring finds a substring, all that stuff, right? So if you just kind of know the name, you can figure out what the string does. So I have to use the replace function, but it takes 3 parameters, right? First one is which index I'm currently at. Second one is how many characters I'm replacing. Third one is what I'm replacing with. So in our case, let me just quickly remove this thing. In our case, I want to replace, so name dot replace the current index, which is index I, comma, how many characters I want to replace? Only one character, right? I only want to replace this character. And what do I want to replace with? The character 3. Okay, so current index, how many characters? Only one character. And what's the new character? This guy, 3. I think this has to be a string actually, not a character. And that will basically replace every small e to a number 3. And that will convert the string Steinberg to st3ien. You get the idea. And once the loop ends, this line of code will basically add or concatenate the c with the st3ien b3rg, and that becomes my new name name string. And that's actually end of the string. You don't have to return anything because it's a void function. And you can just close the string here because it was opened here. Okay. So this is a good question because it uses a lot of the methods that was given in the list. Hopefully it did make sense to you. If you guys don't have any more questions, that is actually the end of the review sessions. But before you guys leave, please feel free to do the feedback form that's in the chat. Oh, maybe we do. Maybe we do. Well, in this question, actually, it didn't even include the, I don't have to write down the extra stuff, right? It's only wanting me to write down the function. Like there's always the main function somewhere in the code that is not given. There's also include IOStream. There is also include, using namespace std, all that stuff. That is not given in the question. You don't need to worry about that. Just worry about what is given and what do you want to write, which is just this function. But maybe you're right. If you want to write the entire function, you may have to write down include string. I'm just not 100% sure if I have to include that or not. But anyway, that is actually the end of the session. Before you leave, just do the feedback form. Quick request. Just runs with just IOStream. Okay, cool. Hopefully the session was helpful. I will stop the recording now. I'll stay for 1 or 2 more minutes. If you have any questions.